Alright, quick death by video here. Bear with me. Reason why I'm doing this is because it's something I'm going to do, but in the meantime, while I get round to doing it, people will find it of interest, no doubt, and may want to go ahead and muck about with this themselves. So I'm looking at diesel heaters and diesel heater resilience and protection. So there's a couple of things which kind of narc me. Well-known conditions where which result in or can result in damage to either the diesel heater or your battery, be it your vehicle battery or leisure battery. So, condition one, I've got this little table here, where you might leave the heater on overnight, fall asleep, and it just runs the battery down. Now, if you've got a lead acid battery, you don't want to take that below 12.2 volts. Otherwise, you then start getting into the realms of chemical damage. So the chemistry starts breaking down. So that's the first condition. And then the second one is sudden loss of power to the heater. You either turn it off by mistake, particularly if you've got an isolator switch like I have, which is well advisable. Done a video on that. Or the fuse blows. These have got a 20 amp inline fuse, or should have, supplying the feed to the diesel heater. And what happens there is that there's this little thing here that I've laid onto the picture of the diesel heater is the location of the control unit, the ECU, the engine control unit for the diesel heater, and it sits on top of the alloy casting for the heater, which heats up. And if you lose power completely, the fan stops circulating air, stops cooling this, and very, very quickly, within a few seconds, you start smelling burning PCB, and it just fries the board. So we want to avoid that. So it is easy to solve both these problems. I want to kind of do them in one hit with sort of one kind of almost plug and play type module or enclosure, so it can be transferred, and it's just neat. So the first one, let's look at the first one. Now this was actually researched quite a bit by David McClukey on YouTube and his community of subscribers. A real David and a lot of the people that subscribe to his channel are real experts on these. A lot of clever people, a lot of engineers, and it's basically an under voltage module, which you can set a predetermined voltage. So let's take, for example, in this scenario, 12.2 volts. Set it to 12.2 volts. It's constantly monitoring the feed into the diesel heater, and if it drops below that level, it will open up a relay and open this circuit and stop supplying power to the diesel pump. Now this is a pulsed output from the diesel heater. Every electrical pulse fires a solenoid in here and shoots some diesel into the heater. What happens is if this stops getting power, the ECU module in the diesel heater sees it as an error, and it will time out with an E8 error, again well documented online. And once it goes into an E8 error, it then throws the diesel heater into graceful shutdown mode. What happens is the fuel's not pumping, but it will keep spinning the fan until the temperature sensor, which is mounted on the body round about here, senses that it's down to a low enough temperature that we can shut the fan off and the whole unit shuts down with an E8 error. And then you've just got to reset it, remove the power to the diesel heater and turn it back on again. Again, another great reason why an isolator switch is a good addition. So that's fairly simple. Taking this a step further, the next condition is sudden loss of power through turning it off by mistake or the fuse blowing. And to get around that, we can use a backup battery. Now that can either be, if you're using leisure batteries to power your diesel heater, which most people probably will be, you can use the vehicle battery potentially as the backup battery. The objective here is not to have the heater running indefinitely on the backup. It's just really to give it a graceful shutdown. So if the power goes, it's not going to kill the fan, and burn the ECU, it's going to allow it to shut down gracefully and cool down nicely. And again, this really needs to be used in conjunction with the undervoltage module. If you are not using a leisure battery to supply your heater, you're just using it. Might be on a bit of plant, for example, a digger, or etc. And you're just using a vehicle battery. You can put in a backup battery, just a little 12-volt, 1.2 amp sealed lead acid battery would be fine for that. Yeah. So how this works? Normal operation. Your supply from your leisure battery, and the relay allows that feed all the way through. We take a feed from this leisure battery to the control side of the relay. This goes down, and that goes down. What happens is it switches over to the backup battery. Now note how we've got the undervoltage module is connected to the feed from the leisure battery, the main feed, because what we don't want happening is if this was connected to the backup battery, it wouldn't kill the pump, and it would still allow your heater to run and probably flatten your backup battery, which, if that's your vehicle battery, that's pretty bad news. So that's basically how that's working. So I'm going to do this. I'm going to get the stuff ordered from FleaBay and get it in. It'll take a couple of weeks to arrive. Busy with work. Might take a while for me to get around to this. So which is why I thought I'd put this video up at the moment and give people the a bit of food for thought. So any comments down below are welcome. Let's have a quick look. I've popped some stuff in my eBay basket. The stuff that would be needed. So first up is the low voltage protection module. There's lots of these out here, lots of sellers. You don't have to buy this one, and they come in a couple of different flavors. This one has a couple of buttons and a display to read out the voltage, and you can program it with these buttons and set your cutoff voltage. There is another one as well where you just make that adjustment with a screwdriver and a multimeter. I'm just going to use this one. It doesn't draw much extra power in the grand scheme of things to light up that display. As you can see, 6 out of 9 delivered. Pretty good. And this is how it works. There's your battery, and then there's your output. So pretty self-explanatory. Again, watch David McCookie's video on these, and he will demonstrate it in operation. My changeover relay, I'm going to order a Durite. I've just got no patience for spending a couple of quid on something that we don't know where it's come from, and it could fail. Durite's a well-trusted brand in commercial applications. It's just over 12 quid, and that is, that's a pretty safe bet. I can more or less rely on that not to fail. And I'm going to order a 20 amp. I don't like things just being right on the limit. I think the maximum we were talking about between 8 and 10 amps for the diesel heater, only when the glow plug is active. But I'm just going to put a 20 amp in. You don't want to put a massive one in, because actually the larger the relay, the more current it draws to hold the to hold the switch open. So that's that one there. The other thing I'm going to do, I'll put the item numbers in the description below as well, which will at least get you started to see what you're looking for, and then you can order whatever variations from whatever sellers you want. The other thing I'm going to do is order a couple of EV1 connectors, a male and a female. And the reason I'm doing this is, and these will go here, rather than cut into the wiring loom for the fuel pump. I don't really like doing that. I want to take this plug here, which would normally be plugged into the pump, and I'm going to put a female connector on there and then another male connector on there, and this is what I want to order these for. So I want to make up my own little sort of pigtail lead to supply the under voltage module. So if there's any problem on the road, at the end of the day, this is a Chinese made module, with just jelly bean parts, and they will invariably, this is going to be the weakest link in the whole system. They will invariably fail. They're cheap enough, But what I'd like to be able to do is if I'm on the road and this does fail, or there's any problem, or I just want to bypass this and remove that functionality, I can just remove this part here and take this plug and fire it straight into the fuel pump. So these are, it's a fairly standard connector. It's a Bosch EV1 style connector, and they are generally used for fuel injection systems. They go in the end of your injectors on cars, motorbikes, whatever. So I'm going to order those, and as you can see, for a pair of them, they're £6. Order them in bulk; they'll be a hell of a lot cheaper. So there we go. And the only other thing is, if you are not using the supply from your vehicle battery as your backup, and you want to put in a separate backup battery, well, this is what I would use. Again, we don't need a massive capacity. It needs to be 12 volts, but we don't need a massive capacity, because if you remember, our objective is not to run the heater for any length of time, and certainly not the glow plug, and start the heater up in the backup. And so it's just really running the fan and the ECU, so we don't need a lot of juice here. So 1.2 amp hour is going to be absolutely great for this application if you do need to put in a separate battery. It's small, and it's also sealed as well, so you can mount this at sort of little strange angles and whatnot to fit it in a cubby hole. Have a look at that yourself. Again, the item number will be in the description. And then you need to keep this topped up. So I saw this. There's lots of modules out there. It's probably twice the price of some of them, but it's got that word there, Germany. So and it's a brand, so probably a bit more trusted. And I'd just rather not have things fail on the road. If I can buy once and cry once, I will. So that's this here. Again, I'll put a link in the description, and you would just put that in line to supply the backup battery with a bit of charging. Once your whole system comes back up and running again, use an isolator switch for your main feed. I've done another video on that. Lots of reasons why. But yeah, so in the meantime, I hope you found this useful. And if it gets people going without any sort of further explanation, that's absolutely fantastic. If anybody has any more further ideas on the development of this, or a better way of doing it, or implement it themselves, and want to post any comments, feel free, fire them in below. The more the merrier. It's useful for the whole community at large. So I hope you found this useful, and yeah, I'll be doing a follow-up video when all the stuff arrives and I get around to actually doing it. Cheers.